All right, so let's start with rotations. Okay, so one thing I want to clear up first before we do anything, if they don't specify a direction in which we rotate, we're going to rotate counterclockwise. Okay, so counterclockwise is like this. Clockwise is like that. The same way a clock moves. Okay, so copy the figure and point P. Draw the image of the figure for the given rotation about P. So the angle of rotation is 60 degrees. So we're going to move 60 degrees this way. Whoops. This way. Whoops. Sorry. Nope. Counterclockwise. This way. I apologize. So we know that my new figure needs to be A prime, D prime, and B prime. Well, if we move it, let's give a little estimate of what it should be like. So if I rotate this way, my A should be here, my D should be here, and my B should be here. Okay, you see how we just shifted it? We rotated it. Okay, so let's take a look here. We know this one doesn't look anything like our figure. This one does. This one doesn't. And this one does. So what's the difference, guys? This is how they try to trick you. They put A here because you're going to be like, oh, look, it's the first one. Perfect. And that's it. But you need to actually look at your figure. What's different between this and this? This guy has the A here and the A here, but it has the B here, and this one has the D here. So what was the one that we said needed to be most to the left? The D. Remember, this D is going to be to the left of the B. So if I were to have 2 points here, the D needs to be to the left of the B. So that's why this is the correct answer, this one. Okay, so let's look at number 2. Okay, draw the image for the figure for a 180-degree rotation about P. Okay, so I'm going to still move counterclockwise. So if I move, so if this is my point of rotation, I'm going to rotate 90 degrees over here. So I'm going to have what? I'm going to have K, and I'm going to have J somewhere over here. And then if I rotate it again, another 90 degrees, I'm going to have K here and J over here. So this is what my final figure should look like. Okay? So make sure that we look for the K and the J. Also, we also need to look out, okay. Another thing that I didn't really emphasize enough, so I'm just going to erase this, was the relation from our K to my J. The K is a little bit above the J, right? So if I rotate it this way, the K should be more out than the J. And then if I rotate it again, if I rotate another 80, this K is now going to be under the J. The K is going to actually be under the J, and it's going to be a little bit slanted up. Okay? That's a very, very big difference. You have to make sure that everything stays with the same orientation. So this K was a little bit above the J. So that means this K is a little bit to the left of the J now because I rotated counterclockwise. And now if I rotate it again, 180, then now the K is going to be under the J. So K prime is going to be under the J prime. So that means my K should still be to the left of it, and my J should be to the right. So let's circle anything that doesn't have a K to the left. So this is gone, and this is gone. Now, these two look super, super similar, but there's a difference. The K here is slightly under the J, and the K here is slightly above the J. So my answer is A, because that was the way that this image was. Okay? So in the figure to the right, point A is the center of the square. What is the image of E? So we're focusing on E for a 180 rotation about point A. So whenever you have a figure and you want to move rotations, you need to look at your center right here. This A is your center that you're rotating upon. How many degrees are in a circle? 360, right? Obviously, right? How many different angles do you have here? I have 4. So divide by 4, which is what? 90. So that means if I move 90 degrees, I'm going to shift one entire movement here. So my E is now going to be where my M is. Now if I move 180, again, my E is now going to be where my P is supposed to be. So this is where my E is. My E is now at point P. Okay? So let's look at this. Point O is the center of the octagon. Okay? So find the image. 90-degree rotation of line segment AH about O. Okay? So now my O is my center right here. How many pieces is this guy going to rotate into? 1, 2, 3, 4, 5, 6, 7, 8. So 360 divided by 8 equals 816. Okay, let's do it. I don't want to take out my calculator. So let's do it the old school way. 8, 16, 24, 32. Minus 32, 4, 0, 45 degrees. So if I rotate 90 degrees, I'm going to rotate how many spots? Not 1, but 2. Because 45 plus 45 equals 90. So let's start. What am I moving? AH. So that means if I move 45 degrees, remember, counterclockwise, 45-degree rotation would land me at HJ. A 90-degree rotation would land me at GF. So my answer should be GF or FG. GH. GF. Okay? So, okay. So now we're going to do 2 reflections. We're going to do a 50 rotation, 150 degree and 140 degree. So what is that in total, guys? Just 90. So now the important part is, where am I moving? What is my point of rotation? The Y. When we start class again, I'm going to really go over the importance of this. What is the point of rotation? It's very important. So for now, my Y is right here. That's my point of rotation. So that means if this is my point of reflection and I move 90 degrees, this Y, your point of rotation never ever moves. Never ever moves. That's why I like to put this little coordinate grid here, because it gives me, I'm making it so that my Y is the origin, in quotation marks. The origin. Because I know that my Y is never going to move. And I'm going to go over that in person more, of why or Y doesn't move, because my Y is the point of reflection, okay? So I'm going to move 90 degrees. So if this is in quadrant 1, once again, how many degrees is this going to be able to shift? 1, 2, 3, 4. So each is going to be 90 degrees. So if this is in quadrant 1, quadrant 2, quadrant 3, quadrant 4, I'm going to move 90 degrees. So I'm going to move it 1. So that means my new figure should be, this is still going to be Y. My Z is going to be over here. And my X is going to be somewhere up here. Not the best artist, but you guys can see what I was trying to do there. Okay? So now, they all look pretty good. The only difference is that they all look like they're oriented correctly. And all the Y's are oriented correctly. What's the only thing that's changing? The Z and the X. This Z's up here, the Z's up here, the X is up here. What did we draw? The X, right? Because this is just going to rotate right here. So my real answer is C. Okay? So now, what is 120 plus 150? That's just 270, okay? So now I'm rotating about point B. So my rotation is right here. So I'm gonna draw a little coordinate plane because that helps me. Now, how many ways can we move? Still 90, 90, 90, 90. So 270 divided by 90, because I want to figure out how many ways I'm going to turn, is just this zeros cancel out. 27 divided by 3 is 3. So that means I need to move 3 times this 90 degrees in order to get to 270. So I'm going to move counterclockwise once again. Counterclockwise. So my first point of reflection is going to land over here somewhere. That's 90. This is 180. And now this in red, we're actually going to do the 270. So my B is still here because remember, my point of rotation never moves. Okay? B prime. So this was my C, this was my A. This was my C, this was my A. So now my C is going to be somewhere here, and my A is going to be somewhere here. Okay? Whoops. Okay, so let's see which one looks like that. Okay, this I definitely know isn't right. That's a 180 rotation. This wasn't even a rotation. This doesn't look right at all. This is the one that looks right. And we can double check. Look, my A prime is over here, my C prime's over here, my B prime's here in obviously the center. And then A's up, C's down. A's up, C's down. So it takes practice, guys. It's hard for me. I think rotations is probably the hardest one for me as well. So it just takes practice, and we'll do a bunch of examples in class, okay? So for something, study the figure. If it has rotational symmetry, tell the angle of rotation. So for something to have rotational symmetry, that means that every time I rotate it, it's going to be exactly the same figure as before. So if I rotate this figure up to this point so that now I have this, are these figures the same? No, it's oriented differently. Wait, I drew that really bad. Something like this. The point, I'm not the best artist, but my point is that if I rotate this guy, let's say, like if this is my center, and I rotated this guy 45 degrees, it would be here, and then this piece would be here, this piece would be here, 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 here. That's not exactly the same. Look, this point is here, this point would be here. It's just not the same figure. So in order for it to be rotationally symmetrical, we need to be able to rotate it in a way that each time we rotate it, it's going to be exactly like this figure over here, like the original figure. So how do we do that? We got to find the lines of symmetry of angles. So this is 1, this is 2, and this is 3. Now, we do have a line of symmetry here, but not of an angle. So that one doesn't count. Okay? So now we have these angles. So now this angle split here, this angle split here, split, split, split. So now, how do we check to see how many degrees are in here? We gotta draw the circle. Now, 1, 2, 3, 4, 5, 6. There's 6 ways that this could rotate, so that if we rotate it across from here to here, it'll be the exact same figure. So 360 divided by 6 is equal to what? 60. So if for every 60 degrees that I rotate this pentagon, it'll look exactly the same. And I will go over that in class more, okay? So don't worry about it, but that's how it's gonna be, 60. Now, let's look over here. Okay, guys, a circle. No matter which way I rotate a circle, it's still just gonna be a circle at the end of the day. So any angle. Any angle, okay? Okay. Now, let's see this, okay? So, tell what types of symmetry each figure has. For line symmetry, sketch the figure and the lines of symmetry. For rotational symmetry, tell the angle of rotation. Okay, so let's see. Okay, so let's look for lines of symmetry. If I have a line of symmetry here, it looks like it's even, but it's not, because look at this angle. The way this is positioned, it's positioned not as a straight line, kind of at an angle. So if I were to rotate it, if I were to reflect it here, it would actually go this way. So it wouldn't be superimposable. Superimposable means that if I draw it, it'll be exactly the same as the other one. So this is not superimposable. This would be, look, I'm going to draw this little piece right here. I'm going to draw this piece right here. Right? If I were to put this piece on top of it, it would look like this. So far, yeah, we're superimposable so far. But once I get here, it would be like this. That's the problem. Okay? So it doesn't have any, and the same thing, if we were to go and put a line of symmetry this way, the same thing. This, once we reflect it onto here, it would be like this. And this would be like this. So it's not, so it doesn't have any lines of symmetry, but it does have an angle of rotation, because if I were to go down here, if I were to have this as a rotation, if this was my line of rotation and I rotate this 180 degrees, then it will land, because if I go up here, if I rotate 90 degrees, it'll go this way. This little piece would go that way. So if I rotate it again, this little piece would then go this way. So they do have a line of symmetry. It does not have a line of symmetry, but it does have rotational symmetry, okay? And the angle of rotation, guys, if I rotate it just 90 degrees, is this the same image as this? Obviously not. If I rotate it 270, this would be down here. Is this the same image as that? No. So the only way I can rotate it is 180 degrees, okay? 180 degrees. Now, same thing for this guy. Okay. If I were to have a line of symmetry here, would these two reflect onto each other perfectly? Yeah, they would. What if I were to reflect it here? Definitely not. Definitely not over there. Now, what about a rotational symmetry? So if I were to have a line here and it rotated symmetrically, notice how this bottom piece is thicker than this top piece. So if I were to rotate it up here 90, it obviously wouldn't match. But even if I were to rotate it down here, this thicker side would be on top of this thinner side. So they wouldn't be superimposable. They wouldn't be two mirror images of each other. Okay? So it doesn't have any rotation symmetry, but it does have one line of symmetry. Line of symmetry? Right here. Only this one. This one definitely not. You could just see how if we were to reflect it, it wouldn't match. This one, yes. This one, no. And definitely not any of these. And it doesn't even have the one that we need, which is that one. Okay, last one. Okay. 180 degree rotation of EC about O. So EC, so I'm only going to focus, if all I'm focusing on is EC, then I'm just going to focus on this shape right here. Which is a what? 1, 2, 3, 4, 5, 6. This is a hexagon. So this hexagon is going to have these amount of angle of rotation. 1, 2, 3, 4, 5, 6. What is 360 divided by 6? I think we've done this already. It's 60 degrees. So how many ways do I have to rotate this guy counterclockwise so that this 60 degrees will match this 180? Well, 60 plus 60 plus 60, that's 180, okay? So that means I'm gonna, what am I looking at? EC. So I'm gonna put in red, EC. So I'm gonna rotate it 180 degrees. So if I start here and I rotate here, how much did I rotate? Just 60. Rotate again, 120. Rotate again, 180. So my new point, my image would be IH. It's right here, okay?